notes for this chapter about acid-base equilibrium is some structural properties of acids and also the way that acids, well, the way that oxides behave in water. All right, so how do we know when something is an acid? So, acids. Is it an acid? Okay, well, we know that an acid is a hydrogen ion donor, or a proton donor in solution. And so there's got to be hydrogen around somewhere. So X is anything, you guys, bonded to a hydrogen. So the question we have to ask is, when does this hydrogen bond into something else, when do we say that this thing is going to act like an acid and it's going to donate that hydrogen ion or that proton to the solution? Well, the answer lies in polarity. If this bond is nonpolar, so for instance, a carbon-hydrogen bond, we say this is a nonpolar bond, that they are sharing electrons equally. And so this is not going to be an acid, not an acid. Okay, they are sharing electrons, nonpolar bond, they're sharing them equally. This hydrogen is not going to dissociate. But if it's a polar bond, like chlorine and hydrogen, it is, yes, an acid. Okay, so the bond between the hydrogen, whatever it's bonded to, has got to be polar. And then that hydrogen is able to dissociate or ionize in solution. More polar bonds will make weaker acids. And that shouldn't be surprising, right? Because if the electronegativity is great, so even though the electrons are being shared more in the polar bond with the anion here, it's still going to make a very strong attraction for the hydrogen with it. So for instance, is HCl a weak acid? No, it's not a weak acid, it's a strong acid. And so the bond polarity between the two is not that great. It's a polar bond, but it's still not that great of a difference. So the bigger the difference in the electronegativity between the hydrogen, whatever it's bonded to here, the weaker that acid's going to be, because yes, the hydrogen will dissociate. So for instance, HF. You know, this thing will dissociate, but mostly it's going to stick with this fluoride because the electronegativity is such that this is going to have the electrons around it most, and so that hydrogen, that positively charged hydrogen, is going to stick to it. All right, now let's talk about oxyacids real quick. Hypochlorous, ClOH, okay, and when we see this written, we'd probably see it as HOCl. Generally, hypochlorous is written like that, or depending, HClO. Okay, so the hydrogen is actually bonded to the oxygen, and for this thing, the Ka is 3.5 times 10 to the minus 8. All right, now let's continue adding oxygens to this thing. OClOH. Okay, what tends to happen with the sharing of electrons, the more oxygens we have over on this side, it actually pulls the electron density in this direction. So this thing is going to be weaker, stronger. 1.2 times 10 to the minus second. If we add another oxygen, OClOH, suddenly now we've got a strong acid. The Ka is about 1.0. And if we add yet another oxygen, ClOOOH, this one's going to have an even greater Ka, right? These are both strong acids. No, not 10 to the minus 7th. 10 to the 7th. All right. So as we have more oxygens this way, it makes the polarity of this bond less and less and less, so that this hydrogen is able to dissociate ever more easily. So weak acid, but as the oxygens begin to build over here, they pull the electron density over of the entire compound, making it easier. The electronegativity of this becomes less and less. And so it makes it easier for this thing to just dissociate and stay dissociated. It doesn't have much affinity back for this oxygen. It's the same thing with this. It doesn't have much affinity back. Here it's still got a little electronegativity. Here it's got a whole lot. And so the more sticky the hydrogen is, of course, the weaker the acid is going to be. All right, let's talk about reactions in water. Covalent oxides. In water form acids. So what are some examples of covalent oxides? So that's non-metal oxides, like SO2, CO2, NO2. Okay, non-metal, covalent, non-metal oxides. So let's take the carbon dioxide that I bubbled into water. So carbon dioxide, CO2 plus H2O is going to give us, okay, there's a couple other steps in here, but this is enough to know. It's going to give us an acidic solution. It's going to give us carbonic acid. Metallic oxides. In water form bases. Okay, so what are some examples of metallic oxides? Like Na2O, sodium oxide, or potassium oxide. Calcium, Ca. plus water is going to give us a hydroxide, calcium hydroxide. Okay. Are we balanced? We're balanced. Okay, so covalent oxides, that means non-metal oxides in water always form an acid. Metallic oxides, so metal with oxygen, always forms a base, the hydroxide.